it's me, Maria Sandoval. Today I will be talking about ionization of elements and a few different trends on the periodic table. So first we're starting off with ranking our elements by our first ionization energy. So our problem is, using the periodic table only, rank the elements in each of the following sets of order of decreasing IE1. A, this is our first set, KRHEAR. B, which is our second set, SBTESN. C, which is our third set, KCRB. And D, which is our fourth set, IXECS. Our plan for this is to find each element on the periodic table. IE generally decreases down a group and increases apart across a period. So we should keep that in mind as we answer these questions. So for our solution, for our first group, A, we are rearranging it in the order HEARKR. And this is because KR, HE, and AR are in group 8A. IE decreases down the group. So KR is at the top and AR is at the bottom. So we're going in order of decreasing. Or, I think it's reversed. So for part B, we're looking at a periodic table and we're rearranging the group B in TE, SB, SN. And that's because SB, TE, SN, and SN are in period 5 and the IE1 increases across the period. For C, we are rearranging group C as CAKRB. And that is because K has a higher IE than RB, because K is higher in the group A1, and CA is higher than has a higher IE1 than K, because CA is further to the right in period 4. Moving down to the final one, our final group, D, IXECS, we're rearranging that as XEICS, because XE has a higher IE1 than I, because XE is further to the right, yet in the same period. CS has a lower IE than I, because it is further to the left in a higher period. That is our first problem with ionization energy. Moving on, if it lets me, it's been giving me a bit of trouble with this. I might just do it this way. We're looking at ionic size versus atomic size. So these are a few trends, a few rules that you'll come across. The cations are smaller than their parent anions. Cations are smaller than their parent atoms, while anions are larger than their parents. Ionic radius increases down a group as N increases. Cation size decreases and charge increases. An isoelectronic series is a series of ions that have the same electron configuration. Within the series, ion size decreases with increasing nuclear charge. And here's a set of isoelectronic series. 3 minus, 2 minus, 1 minus, 1 plus, 2 plus, 3 plus. Moving on, we're going to be looking at another problem. It's on ranking ions by our size once again. So what I would recommend you have a periodic table next to you and try to answer it yourself before we go over the plan and solution. So our plan is to find the position of each element on the periodic table and apply trends for ionic size. So our first solution for that is, for A, SR is 2 plus, Ca is 2 plus, Mg is 2 plus, and all these ions are from group 2A, so size increases down the group. And that's looking at our first group, which is Ca2 plus, SR2 plus, Mg2 plus. Our problem was to rank each set of ions in order of decreasing size and to explain our ranking. So we've explained it and we've done it in decreasing size. So moving on to the next group, K plus, S2 minus, Cl minus. For B, we are rearranging it as S2 minus Cl minus K plus. These ions are isoelectronic, so size decreases as the nuclear charge increases. And for C, Au plus and Au3 plus, Au plus and Au3 plus is how we are going to leave it, because cation size decreases as charge increases. Moving on, we're looking at our trends in electron affinity. So electron affinity, EA, which is how it is abbreviated, is the energy change that occurs when 1 mole of electrons is added to 1 mole of gaseous atoms or ions. Atoms with a low EA tend to form cations, while atoms with a high EA tend to form anions. The trends in electron affinity are not as regular as those for atomic size or IE. So electron affinities of the main group elements are in kilograms, kilojoules, and moles. So here you'll see our electron affinity. Here's 1, 2, 13, 14, 15, 16, 17, and 18. We're looking at our groups, and their affinities are shown below. So here are some overall trends that you'll see in the periodic table for IE and EA. So reactive nonmetals have high IEs and have highly negative EAs. These elements attract electrons strongly and tend to form negative ions in ionic compounds. Reactive metals have low IEs and slightly negative EAs. These elements lose electrons easily and tend to form positive ions in ionic compounds. While noble gases have very high IEs and slightly positive EAs, these elements tend to neither lose nor gain electrons, because they're kind of like noble gases usually do pretty well on their own because they're usually full. So trends in 3 atomic properties. So ionization, as you can see, increases as you go up the periodic table and also increases across the periodic table. Electron affinity increases as you go up, with some exceptions, and electron affinity increases as you go across, with some exceptions. Atomic size increases as you go down and increases as you go to the left, actually. So atomic size is the only one that really changes there. But so thank you so much for listening to me talk about trends in ionic size and electron affinity and all those little fun things. So I hope you had a great time, and I hope you learned a lot, because I learn a little bit more every time I do one of these videos too. Have a great day.